Well, hello everyone. We're going to go ahead and take a break from the unit circle for just a second and all those right triangle and special points and all that stuff and talk about a different kind of angle called a reference angle. So I hope you enjoy the break from the unit circle for just about 5 or 10 minutes and then we'll jump back into it. So the reference angle, for any angle, theta uses this notation, so like theta with a little apostrophe. And what it is the positive acute angle made by the terminal side of angle theta and the x-axis. Okay, so the important parts of that definition is that reference angles are always positive, they're always less than 90, and it's always drawn to the x-axis. So this little caution symbol here, sometimes students draw it to the y-axis. That's not correct. You always should make sure it's drawn to the x-axis. And so a visual here is like this. So if we have our angle, let's say it's 100 degrees. 100 degrees would bring us to the second quadrant, right? And theta would have a measure of 100 degrees. The reference angle is the angle formed by the terminal side of theta, so this side right here, and the nearest x-axis. So the reference angle should always be in the same quadrant as where the angle ends with the nearest x-axis. So this is our reference angle. Okay, so theta is the angle that they give us. Theta is the angle that they give us. But what's going to become really helpful to us is this reference angle in here that tells us how far away we are from the nearest x-axis. Okay, so what I want to look at is what a reference angle looks like in each of the quadrants because it looks slightly different. So the first quadrant is actually the only unique one because in the first quadrant, the theta, the angle that they give us, is positive, it's acute, and it's made with the nearest x-axis. So in the first quadrant only, the reference angle is equal to the angle. So all of our reference angle values actually are going to come from this first quadrant. All of our reference angles are going to refer, so get it, reference angles, they're all going to refer to the points in this first quadrant because they're all going to be the same, okay, in the first quadrant. In the second quadrant, that's different. So again, here's our theta, here's the terminal side. The angle theta brings us into the second quadrant. So the reference angle is going to be made with the terminal side and the nearest x-axis. So this would be the reference angle. Okay. In the third quadrant, if our angle brought us into the third quadrant, see how here's theta from the initial side all the way over to the third quadrant, the reference angle would be formed with the terminal side of the angle and the nearest x-axis. Notice in the third quadrant, the reference angle is kind of nestled into the original angle. Okay. And the last one is what happens if our angle theta rotates all the way around to the fourth quadrant here. So if that's the case, again, terminal side, nearest x-axis, here is our reference angle. Okay, so you can see our reference angles show up in each of the quadrants, in quadrant 2, quadrant 3, and quadrant 4. Okay, always formed with the nearest x-axis, because one of the ways to think about what a reference angle is it's asking how far away is the terminal side from the x-axis, the distance or the amount of rotation. Okay, so one way to think about it is, let's give these angles some values. If this angle is 100 degrees again, how far away is this angle from the nearest x-axis? How would we calculate the reference angle? Well, hopefully if this is 100, if we opened 100 degrees, we would need to go 80 more degrees to get to 180. So all we did really was subtract 180 minus 100. So in the second quadrant, to find the reference angle, you're going to do 180 minus the angle, okay? And we do it in that order because we always subtract the bigger number minus the smaller number, right? So in the third quadrant, how would we find the measure of the reference angle? Well, let's give it a value as an example. So 200 would be an angle in the third quadrant. The reference angle is the distance or the difference between the angle and the x-axis. Well, what's the difference between the two? How far away are we from 180 to 200? Well, 20 degrees, right? And how did we get that? Well, we just subtracted these two values. The bigger number in this case is theta, and then we would subtract 180. Finally, in the fourth quadrant, how could we come up with an expression to find the measure of a reference angle? Well, let's say in the fourth quadrant, this angle is 300 degrees. Well, the nearest x-axis is 360. So how far away are we from the nearest x-axis? Well, from 300 to 360, that's 60 degrees, right? In general, what we did was we took 360 and we would take away the angle measure, whatever it is. So we could write this expression, 360 minus theta. Okay? All of these expressions that we just kind of discussed are written out here. You are welcome to memorize these. However, I think it's just as easy and maybe even easier to just think about it and ask yourself how many degrees away from the x-axis is the terminal side. Okay, so drawing a picture is super helpful as we're practicing and getting the hang of this. So let's practice with these examples. So first we want to draw theta. So theta 245. 245 is in the third quadrant because here's 180, here's 270, right? So 245 would be in the third quadrant. This is theta. Theta starts at the positive x-axis and it rotated all the way around into the third quadrant. Our job is to figure out what is the reference angle. So this angle is the reference angle. Now remember, the reference angle is always going to be the difference between the angle and the nearest x-axis. And then you always do big, take away small. So in this case, the bigger angle is 245. The smaller angle is the 180. So we subtract 245 minus 180 gives us a reference angle of 65 degrees. This terminal side is 65 degrees away from the x-axis. Okay? Number 2, the angle theta is 79 degrees. So notice it's in the first quadrant, 79 degrees. Well, the reference angle is made from the terminal side and the nearest x-axis, which makes the exact same angle. So remember, this is the unique one. In the first quadrant, the angle and the reference angle are going to be the same thing. All right, number 3, 163 degrees. So that's going to take us into the second quadrant. So second quadrant rotating 163 degrees into the second quadrant. The reference angle would go from the terminal side to the nearest x-axis. So this is where the reference angle is. The nearest x-axis is 180 degrees. So the reference angle is going to be the difference between the two. Oh, excuse me, I just sneezed. We're going to subtract 180 minus 163. Always doing the bigger angle minus the smaller angle. 180 minus 163 is 17 degrees. So the reference angle is 17. And the last one, 322, brings us into the fourth quadrant, right? We would rotate all around 322 degrees. The nearest x-axis to this terminal side is 360 degrees. So again, we just subtract. In this case, which one's bigger? 360 is. So we'll put 360 first, minus 322, and we get that the reference angle is 38 degrees. Okay, this reference angle right in here. So why is this helpful? Well, we spent a lot of time talking about the first quadrant in our unit circle, right? If we can memorize this, and you guys remember the hand trick, right? You put your finger down, and then it's the square root of the fingers on top, square root on the fingers on the bottom are your numerators, and then all over 2. So whether you memorize this or use the hand trick to help you, we can get all the values of these special angles in the first quadrant. Well, now if we pair that with our reference angle knowledge, we can actually find the values of a lot more than just these 5. Let me show you. So let's look at this one. Example 1 says find the sine of 120, cosine, and tangent of 120. So the angle they want us to focus in on is 120 degrees. Well, that's in the second quadrant, right? 120 degrees would start at the positive x-axis and go into the second quadrant at 120. Well, we haven't memorized sine, cosine, and tangent for 120 at all. But if we use the reference angle to draw, so if we highlight here and use our reference angle, first of all, we can calculate the reference angle and say that the reference angle, theta prime, the reference angle, 180 minus 120 is 60 degrees. So this angle in here is 60 degrees. And if we use that, if we use the reference angle to drop our right triangle down, now this diagram looks very, very similar to our 60-degree diagram in here. If we were to draw a triangle from here to here, where in here is 60 degrees, right? We can use the same values as our 60-degree angles from our first quadrant here with our 60-degree angle in our second quadrant. So if you remember, if you use your fingers, 60 degrees is your ring finger. If you put your ring finger down, the coordinates are, and I'm just going to move this over so I don't get on that highlighted portion. So if we put our ring finger down for 60 degrees, the coordinates are 1/2, comma, √3/2, right? However, so again, so y and x, cosine and sine, the only difference, the only thing we have to take into consideration, we can't just copy the points over completely because we're not in the first quadrant, we're in the second quadrant. And the only thing that changes in the second quadrant is that x is negative. So we would put a negative in here for x because we know in the second quadrant, x is negative. So now we can figure out, now we can evaluate and say that the sine of 120, well, that's pretty thick. The sine of 120 is the y value, √3/2. We can say the cosine of 120 is the x value, -1/2, because we remember in the second quadrant, cosine's negative. And then we can say the tangent of 120 is the same as the tangent of 60. If you don't remember, look back. The tangent of 60 is √3. And then we just have to remember, in the second quadrant, tangent is negative. So we put the negatives where they belong, but we use the same values as the 60 degrees in the first quadrant. So finding a reference angle actually refers us to the first quadrant values that we've been working so hard to memorize and become familiar with, and it actually opens up the rest of the unit circle to us. We can now figure out a bunch of points in the second, third, and fourth quadrants. So that's what we're going to do. Take a look at number 2. Different example. Now the angle they're asking us to evaluate is cosine, or 210. So 210 is in the third quadrant, third quadrant. So it would start at the positive x-axis, it rotated all the way around to here, 210 degrees. But again, we don't really have a lot of knowledge of 210 degrees, but what we do have knowledge of is the reference angle. So if this is 180, 210 minus 180 will give us our reference angle. So 210 minus 180 is 30. So now, instead of trying to memorize the values of a totally different angle, 210, what if we just use our information that we have about a 30-degree angle? So again, we can look back, we can refer to our first quadrant. This is our 30-degree information. If you use the hand trick, you put your index finger down. You have 3 fingers on top, so that's square root of 3/2. You have your thumb on the bottom. That's the square root of 1 over 2. Cosine, sine, tangent. These values are going to duplicate in the second, third, and fourth quadrants. And the only thing that's going to change is whether or not the values are positive or negative, right? So we're going to take these same values and put them in the third quadrant. So the values are for a 30-degree reference angle. The side opposite of the 30 is 1/2. The adjacent is root 3 over 2, the sine and the cosine. And then we just remember in the third quadrant, sine and cosine are both negative, right? So we can say the sine of 210 degrees is negative 1/2. The cosine of 210 degrees is negative root 3 over 2. And then the tangent, do you guys remember tangent of 30 degrees? That's with all the 3's, root 3 over 3. But in the third quadrant, tangent is positive, so we're going to leave it just like that. In the third quadrant, sine and cosine are negative, so we added those negatives into the values of 30 from the first quadrant, right? We took these values, cosine, sine, tangent, cosine, sine, tangent, right? But in the third quadrant, sine and cosine are both negative, so we put those negatives in. Okay, go ahead, pause the video. I want you guys to do number 3, and take like 3 minutes, then when everyone's ready, unpause and I'll explain. Okay, so pause if you need to. All right, unpause. We're back here. So the way I would do this is say, okay, this is 315 degrees. This is 360. I need to figure out my reference angle first. So my reference angle is 360, the bigger angle first, minus 315 is 45. So the reference angle is 45 degrees. So I have a 45, 45, 90 right triangle in my unit circle. And I refer back to my first quadrant. 45 degrees is root 2 over 2 for both cosine and sine. And then the tangent is 1. So I duplicate that over here. The cosine and sine are both root 2 over 2. Except in the fourth quadrant, sine is negative. So I just remember to put in those signs as I work through. So sine of 315 is negative root 2 over 2. Cosine of 315 is positive root 2 over 2. And tangent of 315, I know the tangent of 45 is 1 in the first quadrant, but is tangent positive or negative in the fourth quadrant? Tangent is negative in the fourth quadrant. So again, you have to add those signs in depending on what the quadrant tells you. Okay? All right, guys, I hope that makes sense. We're going to stop here with these notes. I'm going to continue tomorrow, but really quickly, take a look at the worksheet packet. You have worksheet 8 to complete for homework, and you can probably do this in class if you have time. But notice the questions. We have, what is the reference angle for all of these? And so remember, the easiest way to find the reference angle is to draw a picture. So like 98 degrees. What quadrant is 98 degrees in? Do you guys know the band 98 Degrees? They were like NSYNC, Backstreet Boys, and then 98 Degrees. They were like the third tier. But Nick Lachey was the lead singer. Anyways, it's pretty exciting. 98 degrees is in the second quadrant. The reference angle is made with the nearest x-axis, not the y-axis, the x-axis. So the reference angle would be right here. And we're going to subtract. Here are the two angles. We subtract the big one minus the small one. So we would do 180 minus 98. Okay, and get, what, 82? All right, same thing. Draw a picture to help. There's no shame in it. It actually helps a ton. So 212 is in the third quadrant. 212, where's the nearest x-axis? Well, it's 180. The reference angle is going to be the difference between the two. But remember, take the big angle minus the small angle. Reference angles always have to be positive, so we do big minus small. And that's how we would continue with these, okay? For right now, for homework, don't do the ones with the negative angles. We're going to talk about that later. Yeah, go ahead and skip it. You guys just do number 7. You can skip the rest of them. We'll do the rest of those later, okay? All right, and then we have these. So these questions are just like the ones we did. It's just formatted differently. So I just want to start you off. Again, I would highly recommend that you draw a picture, but at least give me the reference angle. So 30, 45, and 60 are the special angles in our first quadrant. So you can go ahead and just fill those in. There's no reference angle, and it's in the first quadrant for each of these. But what I want you to do, starting with 120, is, again, draw a picture. 120 degrees, 180. Tell me what the reference angle is. So here, the reference angle is 60. If the reference angle is 60, the values are going to be just like this row, the 60-degree row. The only thing you'll need to change is to tell me which values are negative. In the second quadrant, cosine is negative and tangent is negative. So you're going to see the values are going to repeat. Since the reference angle is 60 degrees, we're going to use the same 60-degree values. We can even fill this one in. It's going to be root 3 over 2. Okay. Do sine, cosine, and tangent first, and then take the reciprocals. And notice the column, so it goes tangent, cotangent. So these guys will be reciprocals of each other, these guys, and these guys. Okay, so as you're taking reciprocals, go ahead and do that. Notice they gave us a reciprocal right here. So write this down, common reciprocals. It's nice that the chart gave us that. Common reciprocals, so you don't have to do the work every time. Square root of 3 over 2 is the reciprocal of 2 root 3 over 3. These are reciprocals of each other. Another common one, I'll give this one to you. The reciprocal of root 3 is root 3 over 3. And then I'll be nice, I'll give you one more. For cosine of 45, that's root 2 over 2, same thing with sine. The reciprocal of root 2 over 2 follows the same pattern as root 3 over 3. It's just root 2. So these are common reciprocals, so you guys don't have to do the algebra work. It should save you a little bit of time. But try these out through 17. Fill out the chart. Find sine, cosine, and tangent first, and then just realize these guys are just reciprocals, right? And use these common reciprocals to help you. All right, so do your best on the worksheet. I'll be back tomorrow to finish up these guys up here and answer any and all questions. So don't be nervous if you have any questions. I will be back tomorrow to answer. All right, have a great day. We'll see you tomorrow.